Movie tickets at the Avengers cinemas cost $6 for adults and $2 for children under 12. If 175 tickets were sold on Tuesday night with cash receipts of $750, how many children's tickets were sold? How many adult tickets were sold? Like all word problems, we need to write a plan. So in our plan, in our first sentence, we know that it's $6 for adults and $2 for children under 12. We also know that there's a total of 175 tickets and a total of $750. And like all plans, we need a let statement. Because we're talking about two things, that means we're going to need an X and a Y. So we're going to say that X is the number of adults and Y is the number of children. My word problem involves two concepts. One is money and the other is tickets. So then I know that I'm going to have two equations, one equation that involves money and another equation that involves tickets. So if I look at my plan, as far as money goes, I know I have a total of $750. So that means that one of my equations, the money equation, is going to equal 750. If I look at my next total, I have a total of 175 tickets, which means that my second equation must be equal to 175. So as far as the money goes, I know it's $6 for adults, and adults is X. So when I go to write my equation, 6 and X must go together. When I talk about children, it's $2 for children, and my number of children is Y, which means the 2 and the Y need to go together. And when I'm counting up a total amount of money, I have to add. So my equation for money is going to be 6X plus 2Y equals 750. And then when I'm talking about tickets, I don't know how many adults I have. I don't know how many children I have. However, I know that when I add up the amount, it's equal to 175. So I'm going to take the X, which is the number of adults, and the Y, which is the number of children, and add them together to get X plus Y equals 175. Now that we have our two equations, we need to eliminate one variable so that we can solve for the other. So our first step in our elimination method is we're going to put parentheses around both our equations. And then we're going to take the number on top, the coefficient on the X, and bring it down. And we're going to take the coefficient on the bottom of the X and bring it up and change our sign, which was our crisscross. From there, we want to take the -1 and distribute it to the entire equation on the top. So -1 times 6X, -1 times 2Y, and -1 times 750. This gives us a new equation, and that new equation is -6X minus 2Y equals -750. Then we want to do the same thing on the bottom. We want to take the 6 times 1X, 6 times Y, and 6 times 175, and we get another new equation, which is 6X plus 6Y equals 1050. Now if we combine like terms, our X values cancel out, so we eliminated X. And if we combine -2Y and 6Y, we get a 4Y. And when we combine -750 and 1050, we end up with 300. At this point, we're trying to get Y by itself, so we divide both sides by 4. And when we divide both sides by 4, 4 divided by 4 gives us the Y, and 300 divided by 4 tells us that Y is equal to 75. Now that we found Y, we can go back to one of our original two equations, either the 6X plus 2Y equals 750, or the X plus Y equals 175. If I choose the bottom equation, the x plus y equals 175, I'm now going to take the 75 that I found for y and substitute it in for y in my equation, so that I have x plus 75 equals 175. If I want to get x by itself, we need to subtract 75 from both sides. And we subtract 75 from both sides and end up with x equals 100. Therefore, as a result, x was the number of adults and y was the number of children. So in my answer, I know that there were 75 children and 100 adults. And that is the final answer to my question.